And we're still in 1.4. And we're going to finish talking about the quadratic formula. Then we'll talk a little bit more in detail about the discriminant. And then we'll spend the last part of the class looking at some questions on your practice exams. Our first exam will be next week. So let's go ahead now and look at some more of these out of 1.4 using the quadratic formula. Here's one we'll solve. This one also has fractions. Okay, this one's a little bit different. Now again, we never want to put fractions into the quadratic formula. And notice in this one the x is down below. And we want to clear out the fractions. So our highest power is an x squared. So we're going to multiply all the parts by an x squared. And then in this one, we're going to have to rearrange it so it's in the correct order. So we'll distribute that x squared through, and we get a 5x squared on the left. On the right, what happens is this x squared will cancel with one of the x's here, and that'll leave you then with a 3x. And then the x squared and the x squared, those directly cancel. So that leaves you with a plus 2. Fractions are gone. We need to make sure that it's in the correct order. It might be in a different order, but we always need to make sure it's equal to 0, and the highest power of x squared is first. So now we'll go ahead and move that 3x and that 2 over. Now we're left with a 5x squared minus 3x minus 2 equals 0. It's in the correct order because it's x squared, x, then the number, and it equals 0. So make sure it's in the correct order. Our a is going to be the 5. Our b is the minus 3. So make sure you realize that's a minus 3 there. So b is going to be a minus 3. And then we've got c, which is a minus 2. We need to be very careful with that minus 3 on the b when we plug it into our quadratic formula, because the sign's going to change. So our quadratic formula, again, is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And again, be very careful when we plug our numbers in. So it's a minus b, so we have a minus 3. And we have a plus or minus the square root of a minus 3 squared minus 4 times 5 times a negative 2 all over 2a, which is a 2 times a 5. And we know that double negative at this 3 is going to make that now positive. So we'll write that here in a moment. So next we're going to break it up into pieces. We're going to work with our discriminant first. And our discriminant is a minus 3 squared minus 4 times 5 times a negative 2. Negative 3 squared makes it a positive 9. We have a double negative, so that's going to make that a positive. Then we have 4 times 5 times 2, which should make it a 40. Combining those together, we get a 49. And we're almost finished here. So what do we have left when we rewrite? We have a 3 plus or minus the square root of 49 over, it looks like 5 times 2 is 10. And we know that that 49 is a perfect square of 7. So that is then 3 plus or minus 7 over 10. And break it up to get your two solutions. So that's 3 plus 7 over 10, which is then 10 over 10, which is 1. So there's one solution. Our other solution is going to be 3 minus 7 over 10. And 3 minus 7 makes it a minus 4 over 10, which is then a minus 2 fifths. So what are our two solutions? Well, they're x equals 1. And the other one is x equals a minus 2 fifths here. So is everyone okay with that one? That one broke down pretty easily because that 49 happened to be a perfect square of 7. So we broke it up. We broke out each piece. We reduced. And we got our two real solutions there. One more of these is going to involve us to use the FOIL method. So in the next one, we're going to have to use the FOIL method. So again, we're going to solve. And let's look at x minus 3 times 2x plus 3 equals 5. Now we need to get this in a form that we can work with. So we're going to have to use our FOIL method. So over to the side, I'm going to take the left-hand side, and I'm going to FOIL it out. We've got x minus 3 and a 2x plus 3. We're going to FOIL it. Hopefully remember how to FOIL. First times first. Outside and outside. Inside and inside, and last and last. And be very careful again with your signs. So x times 2x, that makes it 2x squared. Then we've got outside and outside, that's a 3x. Inside and inside, that's a minus 6x there. And then last and last is minus 3 times 3, which is a minus 9. The middles can go together, and that gives you 2x squared minus 3x minus 9. And that still equals now 5. So what did we do first? We got rid of our parentheses. Remember, parentheses is the first thing we need to do. So we got rid of the parentheses by using the FOIL method. Okay, now all the parentheses are gone. What's our next step going to be? Set this equal to now what? We're going to now set this equal to 0. So let's move that 5 over. And we're left with 2x squared minus 3x minus 14 equals 0. And now it's set up for the quadratic formula. So A would be 2, B would be a negative 3, and C would be a negative 14. Our quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. We're going to fill in our pieces. Watch out for the double negatives again. So we have a minus 3, plus or minus the square root of a minus 3 squared minus 4 times 2 times a negative 14. And that's all over 2 times 2. And we know that double negative, well, that double negative here is going to make that a positive 3. We'll work with our discriminant first. And that's a minus 3 squared minus 4 times 2 times a negative 14. So 3 squared is 9. Double negative makes it positive. Multiply across. And that gives you 112. Add that 9 to that, and we get 121. And we're in luck again because 121 is a perfect square. A lot of times they'll be perfect squares. Not always, though. Now rewrite this. Watch your signs. That double negative at that 3, well, that's going to make that a positive. So now we've got 3 plus or minus the square root of 121 over 4. And we know that 121 is a perfect square of 11. Split it up and get our two solutions. So 3 plus 11 over 4. That's 12 over 4. And that reduces down to 3. The other one is the minus 11. So we have 3 minus 11 over 4. And 3 minus 11 should be a minus 8 over 4. And that gives you a minus 2. So what are my solutions? X equals 3. And x equals a negative 2. And you could have actually solved this one with 0 factor. The directions here are going to be solved with the quadratic, so we use the quadratic formula. This one you could actually use 0 factor because these are whole numbers. But we want to solve it with the quadratic formula. All right, is everyone okay with that? I want to do one more that has a negative in front just so we know how to handle that. And then we'll talk about the discriminant. So let's work with one more. And you never want to start the quadratic formula with a negative a. So if it begins with a negative, we're going to have to distribute a negative through to make it positive, because it always needs to start with a positive value for a. And we need to make sure in the quadratic formula that we don't have any fractions. So let's look at one that has a negative value in front. How about a minus 4x squared plus 7x equals a minus 1. I'm going to go ahead and set this to 0, so add your 1. And now we've got a minus 4x squared plus 7x plus 1 equals 0. And again, we never want to start with a negative number in our quadratic formula. If a is negative, you end up dividing by a negative, and it makes it more confusing. So it starts with a negative. We don't want to begin with a negative. So we're going to distribute a negative through and change our signs. So because it begins with a negative, we're going to put a negative out in front. And we're going to go ahead and distribute that negative through. And what is that going to do? Well, that is just simply going to change your signs. So now we have it set up for the quadratic formula. So we've got a positive 4x squared. We have a minus 7x and a minus 1, and that equals 0. So we set it to 0. We made sure that our a was positive, and now we can find our pieces. So a is 4, b is a negative 7, c is a negative 1. Apply your quadratic formula. Which is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a, and plugging in our values. Again, watch your signs. We have a minus 7 plus or minus the square root of a minus 7 squared minus 4 times 4 times a negative 1 all over 2 times 4. We know that double negative in front of that 7 is going to make that positive. Let's go ahead and finish this out. Rewrite it again. I always like to write all the steps out, just so if you're going back and looking at things, you can see them. You can skip some steps if you would like, but I always write out all the steps. That way, when you're going back and looking at the notes, you can see step by step what's happening. Because a lot of times we work things out in class and it makes sense, but you might go home and forget a step or two. So I always write out all the steps. That way it makes sense. We're going to work with our discriminant. And that's just a fancy word for everything underneath that root, which is a minus 7 squared minus 4 times 4 times a negative 1. And that's then 49. The double negative makes it positive. And 4 times 4 is a 16. We'll add those together. And that gives you 65. And if I go too fast through something, make sure you say something. So always say something if you need to. And otherwise, we'll just keep going on. But we've got that 65. Now, unlike the last one, 65 is not a perfect square. So we're going to have to try and break it down. So let's rewrite what we've got. We've got a 7 plus or minus the square root of 65 over 8. And 65, it ends in a 5, so I know a 5 will go in. So let's see if we can break it down. And that's going to break down into 5 and 13. Well, that doesn't help us at all because 13 won't break down anymore. So we've got no pairs, so we can't break this up anymore. So what's our final answer is going to be? We'll split it out. And we've got 7 plus the square root of 65 over 8. There's one of them. And the other one is 7 minus the square root of 65 over 8. So there's our two solutions there. Is everyone okay with that? Right? 65 won't break down. Sometimes they'll break down, sometimes they won't. Might come out to be perfect square. What we're going to look at next is we're going to look more at the discriminant. And there's a table in your textbook. You've got a new edition, so I've got to find the table again. But it tells you what you can work with on this discriminant. So this table is on page 138. So we're going to talk now about this blue table. In some cases, you might want to see what type of answer you're going to get before you actually solve it. And this again is on 138. Now, what can we have? Well, we can have one solution or two solutions, and they can be rational, irrational, or non-real complex. And we're not going to have to work this out completely. All we look at is our discriminant. So we're going to use this table here. We're not going to solve the next ones out. We're just going to determine the number and the type of solutions that we're going to have. So we're going to be determining the number and the type of solutions. We're not going to solve these. And we're going to look at our discriminant. Now, what is our discriminant? Well, our discriminant, in terms of variables, is b squared minus 4ac. And we're going to use page 138 in your textbook. So we're not going to completely solve these out. All we're going to do is use our discriminant to determine the number and the type of solutions that we're going to encounter. Now, they may be in a different order, so we're going to have to rewrite them in the correct order. We're going to set them equal to 0 so we can get our A, B, and C. It's just that instead of using the entire quadratic formula, all we're going to look at is our discriminant. So here's one that we're going to start with. How about 7 plus 4b squared equals 5b. Doesn't have to be an x. It can be a different variable. It can be an x. It can be a y. It can be a t. As long as it's got a square in it, and we can set it to 0, that's what we're going to be working with. So let's go ahead and set this equal to 0. Make sure it's in the correct order. So move that 5b over. Always start with the highest power first. So we've got a 4b squared, a minus 5b, and a 7, and that equals 0. Our A in this case would be 4. Our B is going to be that negative 5 in front. And the last part is that C, and that's a 7. Now, we're not going to solve it out completely. All we need to figure out is the discriminant. So let's work with that discriminant. And again, our discriminant is b squared minus 4ac. And so that's a minus 5 squared minus 4 times 4 times 7. And let's see what that discriminant is. So that's 25. A single negative keeps it negative. We've got 4 times 4 times 7. That makes it a minus 112 here. And now my discriminant is a minus 87. So we're not working it out completely. And this goes along with 13 through 16 in your homework. Now, we've got a negative 87. So let's go back to our table. Yeah, this is 13 through 16. Yeah. So this is, I'll write that down. So this is like homework 13 through 16. Okay, we've got our discriminant. Now, let's go back to our table on page 138. We've got a negative 87. So first off, we'll look at our discriminant. And we've got three choices, or actually four. It can be a positive number and a perfect square. What do I mean by a perfect square? Like 49, 16, 25. Those are perfect squares. It can be positive, but not a perfect square. It can be 0, and it can be negative. So what is ours? Ours was a negative 87. So that means we have two solutions. And what type are they? Non-real complex. That's it. So because that's a negative 87, we have two non-real complex solutions. So we're not actually solving these out. All we are doing is determining the number and the type of solutions. Let's do one, maybe two more of these if we need to. And they're quite a bit easier than using the quadratic formula. So let's try another one. How about 7z squared? And let's use a minus 3. We'll make this one already equal to 0. And let's use a minus z in the middle. So this is what we've got. And again, we're going to determine the number and the type of solutions. So is it already set to 0? It is. What are my A, B, and C? Is it in the correct order? Yes. So my A would be a 7. If there's no number in front of that Z, you can always put a 1 there. So we have a minus 1 for the B. And then C is a negative 3. So our discriminant is B squared minus 4AC. So that means we've got a minus 1 squared minus 4 times 7 times a negative 3. And we know minus 1 is a positive 1 when we square it. Double negative makes that a positive. And multiplying across, we've got 4 times 7. It's 28 times 3 makes it an 84. And we add them together and we get an 85. Okay, so it's a little bit different this time. So we got a positive 85. Let's go to our table. And we know it's positive. Is 85 a perfect square? Use your calculator if you need to. No, 85 is not a perfect square. So it's positive but not a perfect square. So we would get 2 solutions, and they are what? Irrational, right? Let's read your table. So our answer here would be 2 irrational solutions. And if that would have been, let's say, a 25, then it would be what? Then it would be 2 rational solutions, right? But in this case, it's 2 irrational because 85 is not a perfect square. Let's do one more. I want to do one where you have a 0 for the discriminant. So again, we're going to determine the number and type. And let's work with one that's going to make it have a 0 here. So let's say we have a, let's use a x squared. We'll do a minus, and we'll make this a minus 16 over here. And let's use a minus 8x in the middle. So I want you to again determine the number and the type. So first things first, it needs to be set to 0. So add that 16 over. And now it's x squared minus 8x plus 16 equals 0. No number in front of that x squared, so we can use a 1. It helps you can put that in there. So a is 1. B is a negative 8. And C is a 16. We're looking at our discriminant. And your discriminant, again, is b squared minus 4ac. And that's going to be a negative 8 squared minus 4 times 1 times 16. And so 8 squared is 64. When you square a negative, it becomes a positive. On the second part, we've got a single negative, so it stays negative. And 4 times 16 is also a 64. And that gives you then a discriminant of what? 0. Okay? So we know this one's 0. So refer back to your chart. And so what do we know here? We know it's 0. So how many solutions do we have? 1 rational solution. So 1 rational solution because your discriminant is 0. Okay, let's go ahead and take another short break, and then we'll come back and we'll spend the balance of the class working on that practice exam. And whatever we don't finish on that practice exam, I'll post a worked out key when I put the notes up so you can check all your work if you need to. Okay, so let's take a short break. And let's meet back here at 8:30. So let's try and meet back here at 8:30.